Hello and welcome to another video in this our R series. It's a brand new day. So today we are going to be talking about two important stuff. We'll pick up from where we stopped in the last video, talking about type conversion, type casting, what we need to do it. Then we'll move ahead into mathematics in R or R math, how you can use R for mathematical operations and see what operators are, what they can do, what they can't do. Because at the end of the day, at the point of data processing or data manipulation, even at times during data wrangling, you just need to do some mathematical operation to get what you need. That's if all the inbuilt functions are not acting the way you want them to act. So without further wasting of time, let's just go straight into what we have today. In the last video, we talked about typecasting, what we needed to change from one type to another. For example, we talked about having a type of a character and a type of an integer. So let's try to concatenate these types together. So concatenation, you use a plus sign to concatenate these. We want to join it together in R, but we don't know if R even allows that. So let me run these objects line by line. So I have the objects out where I want them to be. So you can see it's giving me an error. It says age and new age, non-numeric arguments to binary operator. So for some reason, it's not concatenating. We could even try to use the paste function for both of them. So paste actually join them together but return them as a string. If I proceed to do this operation in mathematics, it will do a 45 plus 45 and it will return 45 45, which is a logical error. So how can I resolve this and ensure that these guys are actually concatenating together the way I want them to concatenate? That means they must all be of the same type. Either they are all strings or they are all integers. You can see their difference. Age is string here, new age is integer. So I picked up a string or a character, I converted it into a new type and it returned another class, another type. So, like I said, understanding the data type is very, very important. We have other guys like from as numeric, we have as integer, we have as complex. So just use one of it, which is as integer. So let's move to one of the fun parts of R, which is R math. What R is actually built for, like we said, statistical, mathematical operations. This is the strength of R programming language. So we all know what operators are in mathematics: the plus, the minus, the times, the modulus, the exponential, and all those things. So we can use R to perform all of these operations on values. So we have a couple of operators that um, we need to be aware of. Either you're a programmer, you're a non-programmer, you should be able to know a few operators, the operators that belong to arithmetic, the operators that belong to assignments, the operators that belong to comparison, logical operators, and couple of miscellaneous operators here and there. So we start from arithmetic operators that we are all familiar with: the plus, the minus, the times, and all of these things. So let's say we just want to do a quick summation. Yeah, we just want to add a few numbers. So let's add, we are calculating discount. Let's say business we sold, we are calculating discounts. I'll call this sales price. So we'll just look at it from business dimension or business angle, so it doesn't look so abstract to us. Sales price is 45,000 naira, and then discount happens to be um, maybe 7.5% of that. So 7.5%, we know what it is. That's 0.75 of what, of the original price we have of sales price. So if I run this, definitely I will see an error because I've not added this object. So let me add this object, and now I have a sales price here, and a discount is a 0.75 of that. Then we go ahead and say maybe final payment. We assign this to be um, discount. Just it's just all about assignment. Final payment is discount. If I want to see final payment at the end of the day, I can just go and final payment is a discount. No, final payment should not be a sales price minus discount. Rather, yeah, difference of this and this should give us our final payment. So we want to see what our final payment is. We can call the final payment. So this is basically what we have at the end of the day. This was sold, or this is advertised to be sold for 45,000 naira. You got a 75% discount, and you ended up buying it at 11,250 or something. So basically, you can see operations coming and going here. We're already using the times, the minus, we also have the plus, the divide. This is modulus, this is exponential, and this is an integer division. Again, I'll go over it: plus, minus, multiplication, division, modulus, raised to the power, or exponential, any one of it that comes to your mind first, then integer division. This guy is a very vital guy in logic building. Very, very vital. So let's just take that alone and see what a modulus is. Modulus in mathematics is the remainder after every division. For example, if I go ahead and say remain, I want to assign remain to be 10. Now let me just do a 9 modulus. In other programming languages is just 1, but in R, um, it returns as 2. So 2 percentage signs is modulus in R. But Python, JavaScript, and all of these guys is just 1 percentage sign that is modulus. So percentage is not percentage per se. You can see 9 modulus 2, it's saying is 1. So what is a modulus? A modulus is the remainder after division. As easy as that. So let's say you are building a game, or you are doing something, not actually building a game. You are working with data, and you want to see some salary based on criteria, or even say you want to see even numbers, numbers that are even, or numbers that are odd, and all of this. So we can always use modulus. What are even numbers? For example, even numbers are numbers that when divided by 2 returns 0, or divisible by 2 without any remainder. Let's take this 10, for example. It will return a modulus of 0. So we know that this is an even number. So that means you can build a logic around this. You can build a logic around this. Let's build one logic before we either break it up into another video or continue with this, because I really want you to have a detailed understanding of what modulus is. It will come in handy whenever you are doing your data manipulation and other things. So let me just say, if I already give it a remain, if after everything we do we have a remaining, and the remaining is actually 0, we want to say print, for example, um, let's print a character that says pay him. So anybody that will divide by their salary by 2, or you divide it by 2, or you multiply it by half, and it's giving you 0, that means we want to pay them. If not, we want to say just a simple logic now that we are building, and don't uh, pay him. So this is the condition we are checking based on the modulus we return. So let's see what this guy returns for us. So this guy say we should pay him. Why? Because 10 modulus 2 is actually 0. So let's say his salary is 9,999 naira. 900 and is quite 9,999, yeah. So if I'm running this now, I need to run this into memory, then run this entire if block, and it says don't pay him because yes, the salary did not return as an even salary. So you get the whole idea of modulus. It checks for remainder after a division, and you can use it to build your logic. Most of the time it works. So we've talked about our assignment operator, which is this that we have been using all this while. Assignment. So the good thing in R is that you can assign from left to right or right to left. What does that mean? Let me call this um left right. Left right, more like a military kind of thing. So 45. This is one kind of assignment, a general kind of assignment. But if for some reason you decide to do 45, that means you will do the negation of that particular sign. That's if this makes sense to us. So this is one of the assignments, and you can see let's try 45. And um, let me change this value so it's not confusing when we see it in. And it says right, left 55. So either you are assigning this way or you are assigning this way. R doesn't care. It just creates an object for you. So unlike other programming languages that read from this side all the way this, so R has a different kind of behavior on its own. So either you assign this or you assign like this. Whatever the case is, your assignment will still work. So we have comparison operators, of course, less than, greater than, less than, equal to, greater than or equal to, and not equal to. Here they are, all of them. We are going to use them when we are building our logic. You have a few logical operators as well. This is the AND. That means conditions must be true. This double AND works on statements, while this particular AND works on expression. This pipe symbol is for OR, and this double, of course, like the AND, works on statement, and this is always a not. This is always a not. You can use a not at times to switch the state of your logic. For example, if I say home, mostly if you're using logical, we like using um, caps lock. If I say is home and I made it true, I can go ahead and say print. Let's see what this gives us. For some reason, not is home. So is home initially is actually true. And I say print not is home, you can see it returned what? False. So whenever you're using the not, it will just negate the truth value to a false, or just a negation. Basically, that's what it is. You use most of these guys when you are building your logic. So the last thing we want to check before we end this video and plan for another one is this particular miscellaneous operator. If you are coming from Excel background, you should know whenever you see a full column in Excel, it means you want to build a series, or you call it a range. For example, I can go ahead and say counter, assign it to be a range of 1 to 10. You understand? Then automatically you see it here. Counter is now an integer value between 1 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this particular operator gives you a range or a series, basically, of numbers that you want to work with. But then, just a bonus for this video before we end it. If I just want to loop through this, you might have been hearing loop, loop, loop. Don't worry, you'll see a lot about it. So you can always write a for loop. For you have your condition in here, and you have um your response inside. That's what a for loop looks like. So we are going to come to a for loop and all of this. Let me not just complicate the matter. So quick question before we end this video. Let's say you are looking for some reason, you are looking for age that corresponds to even number for some funny reasons, and then they gave you a data set. You're able to extract the age column, and now you want to check the entire age column and just return a compilation of those ages that are even number. How do you think you're going to approach it? Just come up with a solution and paste it in the comment section of this video. Let me take a look at it. Then in the next class, that will be the first thing we are going to talk about before we continue. So let me just note that down as even age checker or calculator. So see you in the next class. Bye for now.